Hey, yo, what up? It's your boy, Mr. Oldridge, aka Chemist Nate, coming at you live with a titration. Just testing it out before we do it in the lab in Chemistry 11 today. I got 10 milliliters of hydrochloric acid, and I don't know what concentration it is. It might be about 0.3. And I filled my burette here with 0.25 mole per liter NaOH. Now let's just take a reading of that to see where we're starting. Where's my glasses? Looks like we're starting at 3.25 milliliters to start. Now, we're going to slowly drip this NaOH into here, knowing the concentration and volume of this and the volume of this, 10 milliliters, we're going to be able to figure out what the concentration of this is. You ready to go? I'm ready to go. Let's get it. Now, I'm guessing I'm going to need a little more than 10 milliliters so I can aggressively get the, oh boy, I saw a little bit of pink there already. The phenolphthalein indicator that I've added to this will cause it to turn slightly pink as stuff drips in. Oh boy, I'm actually working with a broken burette here, and the NaOH is dripping down my stopcock. That is bad news bears. It means I'm going to have to touch it to get it to stop. Let's see if I can show you some of the pink here. Dun, dun, dun. Yeah, it's going to take much more than that. Drip. How do you make a burette drip? Slap a Supreme sticker on it. Drip, drip, drip. I don't know if you can see it turning pink in there as the drips go in. This is where all the action is. Anyways, you don't need to see me. Oh, you can definitely see some pink in there somewhere. The NaOH causes the phenolphthalein to go pink, but the acid that's in here reacts it away, so the pink color disappears. A titration has stopped when the pink color stays. That means you're out of the acid that is neutralizing the sodium hydroxide as we go. Looks like we've added about 6 milliliters. I'm actually estimating it's going to take us 12. I'm just going to open this a little more, let it drip a little faster. Nice. I don't know if you can see that pink color showing up. You definitely can. Drip, drip. At least the drip's coming from the proper part of the burette now. Sometimes we have a little magnetic stirrer under here that will stir it for us. Would you like to see that? Yeah, I bet you would. Oh, we're at 12 already. I don't know how much longer this is going to take. Just going to throw in a little magnetic stirrer here. Turn that on to slow. Look at that. It's stirring it for me. What a world we live in. Chug, 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 chug. I'm going to keep letting this base drip in there. But again, I anticipate this finishing up pretty soon. You know what? The pink color isn't really staying. You can see it appears very briefly. Drip, drip. Would you like to watch that stirrer go faster? Oh, Jesus. Oh, that's a bad. Don't do that. Well, now I have to be, damn. Well, I've done worse. Just have to wash the walls of that so I don't lose any of my acid. There, I'm my own magnetic stirrer. Oh, the pink seems to be staying a little bit, but it's not forever, you know? Oh, I got a phone call. Hey, I'm doing a titration. Can I call you back? That's what I say to exes. And then I never call back. Oh, wait. Oh, it disappeared. Thank goodness. I definitely thought we were near the end. This magnetic stir really isn't doing it for me the same way. Oh, there we are. There we are. That's it. That's it. The pink color is here. I added an extra drop, so it's extra pink. Sucks to be me. I'm just going to make sure I've washed all the acid from the walls of my beaker away because I foolishly turned. Yeah, there you go. We're donezo magrunzo. Let's take a reading of that burette up here. It says 15.2. So let's take a little walk over to the whiteboard so we can do a calculation together. So here's the idea. The idea is that the NaOH that was in the burette itself started at, I estimated, 3.25 milliliters, and we ended at, what did I say, 13.2? Let's go look at that again. Oh, 15.7. I was not even close to what I thought. That's 15.7 milliliters, which means I added 12.45 milliliters of that 0.25 mole per liter NaOH. Now in my beaker, I know I had 10 milliliters of the HCl. Look at all the sig figs I get from a graduated pipette. But unfortunately, the sig figs from my NaOH concentration are not that good. Now it's a 1-to-1 ratio, so I know the number of moles of NaOH has to be the same as the number of moles of HCl. What that means is I can do number of moles of NaOH is C times V. That's 0.25 moles per liter times 0.01245 liters. I don't know what that gives me. Where's my calculator? 0.25 times 0.1245. Oh, I forgot a 0 in there. That's 0.0031125 moles of NaOH. Now it's a 1-to-1 ratio, so I know it has to be the same number of moles of HCl. And I know my volume, so I can get the concentration of the HCl from N over V. It's this number divided by 0.01 liters. When I do that, I get 0.3113 moles per liter. That's the concentration that I estimate the HCl to be, which makes sense because I thought it was about 1/3 of a mole per liter, or 0.33. That's not too bad. You know what that means? The experiment's going to work. We're going to have some good times in Chemistry 11 today. Be there or be talked about. Peace.